Thank you. Good morning. I'm Thomas McFarlane, and a subtitle for my talk might be Science from Non-Duality. Hopefully that'll clarify itself as we go. First of all, I'd like to make a few acknowledgments. This work is based on collaboration with Joel Morwood from the Center for Sacred Sciences in Eugene, Oregon. Those of you who were here last year may remember Joel. He was one of the speakers. Also, this work is inspired by some of the work of Franklin Merrill Wolff. Some of you may be familiar with him. He's the author of The Philosophy of Consciousness Without an Object, among other books. He's an American philosopher and mystic. So science and non-duality, how are these related? I'd like to take a step back, get some perspective on this conference and what it really means to talk about the relationship between science and non-duality. What is science? What is non-duality? Well, one way to look at this is to look at the different traditions and paradigms in science. We have classical physics, for example, and after that developed quantum theory, and presumably we'll have future physics as well. We don't know what form that will take, but no doubt as paradigms have changed in the past, they'll continue to change in the future. We don't know what that'll look like yet. But these paradigms will continue to change, and the question will arise over and over, how are these different paradigms related to non-duality? Well, in the non-dual traditions, we have a variety there as well. We have, just to take a few examples, we have Madhyamaka Buddhism, one expression of non-duality, very sophisticated philosophy. We have Advaita Vedanta, and we may well have future non-dual traditions evolving today and taking form. And so how can we relate these to each other? Well, there have been some pioneering works relating quantum theory with Buddhism and Advaita Vedanta and other Western traditions. For example, we have the well-known classic, The Tao of Physics, which discussed some of the parallels between modern physics and Eastern traditions. And a work that came out 10 years ago by myself, Einstein and Buddha. This is a collection of parallel sayings, quotes from various traditions, showing some of the provocative parallels between what some modern physicists have said and what some sages from the Eastern traditions have said. And so the question arises, well, what's beneath some of those parallels between these traditions? Well, then the question, even if we did start to answer that, what might be the parallels between a future physics and future non-dual system? Well, those haven't arisen yet, so we'd again have to revisit this question of how is science and non-duality related to each other? And of course, there'd also be questions of how that relates to past traditions and how the future physics relates to these other traditions and how future non-dual traditions might relate to older paradigms. And as you can hopefully see, this starts to get very complicated. And the reason it gets complicated is because basically we're working in a realm of duality here. Although these are expressions of non-dual wisdom, non-dual traditions are expressed in dualistic terms in conceptual philosophies and so on. And so we're in the realm of duality there, and of course in science as well, in the realm of non-duality. And we're faced with a complicated task that will continue to change as our paradigms change. So is there a simpler way to go about all of this and to understand the relationship between science and non-duality? Well, non-duality is extremely simple. It's perhaps the most simple non-thing you could imagine. And so if we begin there, then the question is, well, how from this non-dual ground can we see science arising? Not just a particular scientific tradition, but all scientific traditions. How can we see these as all emerging from some common ground? And similarly, presumably, from this common ground arises everything, and so of course the non-dual traditions will also arise from this common ground. And so I would propose that one way to approach the relationship between science and non-duality is not so much to look horizontally between these different dualistic conceptual systems, but rather to trace them all to the simple root from which they emerge. And by doing this, we might have a more profound insight into how science and non-duality might relate to each other. And so really, the metaphor here is more of a tree from which all of these spring from a common root, rather than looking at how these branches might relate to each other. So we really need to drive to the root here, to move from complexity towards simplicity, and see what really are the origins of science. And so we need to look carefully at the ground of non-duality and how science might be seen to emerge from this very simple ground. Now the ground, of course, is non-dual, but science is the realm of duality. So the first thing we confront is the primordial distinction between duality and non-duality. And of course, that being itself a distinction, it is already in the realm of duality. So here's a paradox that must be faced from the get-go in discussing how science, or really anything, would emerge from non-duality, and is it really dual in the first place? So the very word science etymologically derives from an Indo-European root that means to cut or divide. So it's important to remember that we are in the realm of at least imagined distinctions. Even if the distinctions aren't real, at least we should acknowledge that these are imaginary distinctions. And science also deals with the objective world. Now, this becomes problematic as well, relating science to non-duality. If science purports to be discovering laws about space, time, matter, and energy, and these laws are supposedly objective to all observers, how do you square this with some of the teachings of the non-dual wisdom traditions, which proclaim or testify that basically there is no such objective reality in any absolute sense of it? So, science from non-duality. To understand how we might trace science back to its non-dual ground, we can first just remind ourselves that the scientific method is based on performing experiments, developing theories, and relating those two. There's a dynamic relationship between our theories and our experiments, our hypotheses, and so forth. Now, the experiments in modern science, the power of science comes from the fact that these are quantitative measurements. And the power of our theories really rests in the mathematical formulation of our theories in terms of equations. And these are related to each other, of course, in the sense that our measurements are, if our theory is confirmed, solutions to our mathematical equations. So we're matching up, and vice versa. We can take our mathematical equations and make specific quantitative predictions. And so our theory and experiment are both rooted, really, in mathematics. Our measurements are quantitative mathematical numbers, and our equations are mathematical. And so we can trace both of these branches of science down to mathematics. And recent work has shown that mathematics can be seen as a system of distinctions. And this is something I'd like to show you using some concrete examples. Because if we trace all of this down to a system of distinctions, which really can be seen as replications of one distinction, then we've traced science and really all duality back to the source of the first primordial distinction, which is the jumping off point to the non-dual ground. So consider dropping a ball from a building. Now, so far, if we drop this ball from various heights, we don't really have science yet. We simply have a qualitative sense of dropping a ball from different heights, different durations of time that they fall. Now, to develop a science from this, first we need to imaginatively superimpose upon this seamless non-dual reality some distinctions. And this is done in science in the form of calibrated measuring instruments. And here, just to illustrate, you can imagine overlaying this building with a sequence of lines representing different heights. And we correlate these with quantitative numbers. Similarly, for time, we need to make distinctions within time. So we imagine a sequence of distinctions in time, and we correlate those with numbers. And we call that time. And now when we drop a ball from a height of 9, we can measure it quantitatively using these distinctions. And we can measure the time quantitatively using the distinctions. And similarly from other heights. We can drop it from 4, we find a time of 2. We can drop it from 1, we find a time of 1. And of course, if we don't drop it at all, 0 height, 0 time. So we've taken this qualitative experience, we've superimposed its distinctions, correlated them with quantitative values, and now we start to have science. We have these measurement results, these quantities, and we can discover a relationship between them. And in this case, the relationship we find is that in every case, if we square the number for the time, we get the height. Now we can forget or blank out this original seamless experience and abstract our systems of distinctions, our imaginations, and we can create a graph of this relationship and interpolate between the actual measurements, and then we can make a prediction of how long it will take to drop a ball from a different height that we never even measured yet. And then we can go out and attempt to verify that. So this is meant to give you a sense of how science can emerge from this basic act of imagining distinctions in our experience. Now what about the numbers that we correlated with those distinctions? Well, 0 could be symbolized by a blank space. And 1 could be symbolized by making a single distinction in space between inside and outside. And by simply replicating this, we have 2. And similarly with 3. This is just like counting pebbles. So if you want to add 2 distinctions to 3, you just put them side by side and you get 5. It gets a little bit more complicated if we want to do more sophisticated arithmetical operations such as multiplication. So to do this, we might imagine a second type of distinction. Instead of a circle, you have a square. And these might be related through a relationship such as this, where the square and the circle cancel each other out. So any expression within those 2 distinctions can reduce to itself. So multiplication could be represented by taking 2 forms of distinctions and embedding each one in a square and surrounding them both by a circle. So this would be the paradigm for multiplication. So if we were to multiply 1 times 1, we'd put squares around each one of them and put a circle around both. Now using this rule, that the 2 distinctions cancel out, those 2 inner forms dissolve. And we're left with a single distinction, which is 1. So 1 times 1 is 1. We can do a little bit more complicated arithmetic. 2 times 2, we use the paradigm for multiplication here, put boxes around each and encircle them. I have to pull a rabbit out of a hat here and tell you that there are other transformations between distinctions that we can develop, so that this form, basically something analogous to the distributive law, can be transformed into 2 forms of distinction. This reduces, using the rules we have before, to 4. So we have quantities represented by distinctions. And we have the operations between the quantities also represented by distinctions. And so our measurements of time and of distance can all be represented or understood as distinctions. And our equations that related them to each other can be understood also as distinctions. And so here our original experiment can be expressed using no numerical quantities at all, simply systems of distinctions, and they're related by systems of distinctions. So here we've dropped from 1, we get a height of 1, and this expresses the relationship between those measurements. So more of the details of this particular mathematics can be found in a white paper that I've written that's available on the web. It's called Distinctions and the Foundations of Arithmetic. That's the URL. You can also simply Google my name or go to integralscience.org and you can find that. And the basic outline of this paper is that it starts from non-duality, develops the first distinction out of that, and then builds upon the first distinction to develop numbers and arithmetic, and from that arithmetical operations and algebra. The work that lies ahead in this project is to further develop this to show how it may be possible to express calculus in terms of distinctions. And this, of course, would be needed to take the modern differential equations, which are typically used to express modern laws of physics, and trace them all the way back to the original first distinction. So from our non-dual ground, we have our first distinction. Out of that develops mathematics. Out of that we have both our quantitative measurements, which are distinctions, and our mathematical equations, which are distinctions. And these are our experiments in theory, which form the basis of science. Now this is a general framework. It isn't restricted to classical physics or quantum physics or any future physics. So this is not a paradigm, but what you might say is a meta-paradigm. It's a way of understanding how all science, or any science, is related to non-duality, by taking science in the most general sense and tracing it back through imagined distinctions, the very way in which we construct our world from our experience. So with this vision of what science is and how it relates to non-duality, science itself becomes, or has the potential to become, a way for us to realize that non-duality. So our very activity of doing science, if it's understood in this way, can be seen as superimposing these imaginative distinctions upon the seamless non-dual reality. And through that, physical science can be a way of realization. And so what is the objective world in this scheme of things? Well, these are simply patterns or conditioned ways in which we divide up the world in replicable patterns of distinctions. And our laws are the relationships between those distinctions, which we find are invariant to various experiences. And if we let all of that go, we can always access the non-dual reality. So thank you very much. And if there's any time left, we maybe have some questions.
That was very interesting, but I didn't understand how you even got off the ground, because how do you get from non-duality to distinction? See, distinction seems to be the epitome of duality.
Exactly. So how do we get something from nothing? Or perhaps we never do. I think that's not a question that has an intellectual answer. Ultimately, the mystery of how something appears to arise from nothing is something to be realized. If there were a conceptual answer to that, that would just be more duality. I hope that's a satisfactory non-answer to the question.
Since it sounds like you're fairly familiar with Franklin Marowolf's work, could you comment a little bit on what you think of statements that he said about basically the inherent limits of science in terms of being able to make definitive statements about whether non-duality exists or not, without existing? I just want to get your take. You seem to have some very interesting things to say about how far it is to go about saying something doesn't exist.
Right. So for those of you who aren't familiar with Franklin Marowolf, he was an American philosopher who started out studying mathematics at Stanford and then went on to graduate school at Harvard and studied philosophy. And he abandoned an academic career to pursue realization of non-duality. And in 1936, he attained that and wrote quite a bit after that. Now, the question relates to some of his comments as to whether it's possible to establish or prove that non-duality exists. And his conclusion, which he viewed as inevitable but unfortunate was that it isn't possible from the basis of conceptuality and philosophy to prove the existence of non-duality, because basically non-duality is what's presupposed by all philosophy and by all our thought and duality. So duality cannot prove its own ground. For example, in mathematics you have axioms and you have rules of inference, and from those you can deduce conclusions, but you can never prove the axioms themselves. And so similarly, non-duality is simply the ground or the context in which the philosophy takes place. So there's no proving it, but there is a realization of it, which is beyond a conceptual type of proof. So perhaps if you broaden your definition of proof, you might say there is a proof of it. The proof is non-dual realization itself.
Do you think maybe perhaps mathematics would be a better way of describing that condition or the ground of being as a kind of a language rather than necessarily saying proof?
Yes, I think mathematics is a very precise and abstract language, and in fact, Franklin Merrill Wolff's view was that because of that very abstraction, it's one of the best ways to communicate or express the subtlety of not perhaps non-duality itself, but we can get closest to it, you might say. The limits of the dualistic mind can be brought closest to non-duality, perhaps through mathematics, because of its extraordinary ability to express such subtlety. Yes. All right. Well, thank you very much. It's been a pleasure. I'd be happy to talk with you.